Good morning. It's my great pleasure to introduce Dr. Heidi Colleran, our morning's plenary. Thanks for all turning up so early. Heidi comes to us from the Max Planck Institute for Evolutionary Anthropology. Heidi did her PhD at UCL with Ruth Mace, and then followed by a postdoc stint in Toulouse at the IAST before moving to Max Planck. Her doctoral research was focusing on the cultural evolution of reproductive change in rural Poland, a field site which you're still associated with, as well as going much further afield and doing some fieldwork in Vanuatu on a range of interdisciplinary projects, and she is head of the Birthrights group at Max Planck, and today she's going to tell us why there's no such thing as natural fertility.
Thanks, Paula. Can you hear me okay? Great. Thanks so much for the invitation. It's a real honor to be here in front of the crowd that I've come up with. This is going to be a mainly conceptual talk with a bit of modelling in there, so hopefully not too heavy for a morning talk.
Hey, sorry, I can't hear you well, actually.
You can't hear me? Okay.
This is really just
Yeah. It's on. Is that better? Should I just hold it like that? I can hold the microphone, that's fine. Yeah. Let's do that. Yeah, that's fine. Is that better?
That is a lot better, but I don't want you to be like...
I'm going to be like, all right, let's do it like this.
I'm sorry, thank you.
Okay, so so I want to convince you that there's this core idea of natural fertility that permeates our field and allied disciplines, including demography, and I want to convince you in this talk that we should stop using it, basically. I want to start by introducing the research team that I have the privilege of working with at the Max Planck Institute in Leipzig. We are an independent research group, and our aim, broadly speaking, is to understand the diverse ways that people organize their reproductive lives and how that impacts demography at different scales, including, ultimately, genetic and linguistic variation. And to do that kind of work, we have to draw on a very wide range of disciplinary sort of backgrounds. So everyone in the group is coming from different backgrounds, either whether it's social anthropology, computer science, we have a political scientist, and we have people with public health training. So our broad aims are, on the one hand, to respond to what we perceive as a significant gap in the understanding of demography in cultural evolution. We want to bring more of it into the field. Reproduction does not happen in a cultural vacuum, and so we focus on interconnected questions about the feedback between individual level decisions, what we call cultures of reproduction, and how those things feed back onto demographic properties, which themselves, of course, feed back again into how individuals make decisions. And on the other hand, we want to bring the vast ethnographic literature that is based on over 150 years of fieldwork around the world to bear on how evolutionary scientists do demography. So things like marriage practices, kinship structures, cultural age structures, fertility regulation, infertility regulation. These are just the tip of the iceberg of human cultural diversity, and we know almost nothing about how these things impact demographically relevant behavior, in particular at scale. So the questions that we're interested in are, what are the signatures of enculturated demographic behavior, and vice versa. Our lack of understanding of these phenomena really drastically limits our imaginations when we're trying to think about human demographic behavior now, but also in the past. And this gap is becoming ever more important as the field of ancient DNA gets closer and closer to the areas that we call home. So these are two papers published in the last few years on which I was a co-author, but I was the only anthropological advisor on these projects. Now, geneticists are getting ever more fine-grained genetic data from burial sites. They're creating pedigrees from those data. But there's a gap here, because genetic pedigrees, as any anthropologist knows, are not the same thing as kinship systems. Or are they? We just don't know. We have no expectations that can guide appropriate inferences here. And if you're interested in an application of how we're trying to tackle this, I suggest that you go to Willem Church's talk this afternoon in the methods and theory section. The point here is that natural fertility, for me anyway, is ground zero for building theoretical answers to all of these kinds of questions. And one of the reasons I think we haven't focused on it is because we're kind of obsessed with genetic kinship ourselves. So you probably know that in 1839, Charles Darwin married Emma Wedgwood, his first cousin, and also his sister-in-law. And of course, like many gentlemen of his time, finding a spouse amongst your family members, amongst your cousins, was a conscious strategy. It was an important family concern. And of course, in the West, we're familiar with this kind of genealogy, but only about 11% of the world's societies organize their families in this way. But because this structure happens to match on really well to how we calculate things like genetic relatedness, it's very easy to think that this is the template, the cultural template for all of humanity, and we export it to the rest of the world. But that's not the case, because kinship organizes populations in very diverse ways, often that have little to do with genetic relatedness, and we haven't really taken those critiques seriously yet in the field. Because of course, if Darwin had been born in Hawaii instead of 19th century Britain, Emma would have been classified as his sister, making their marriage impossible. Had he been born in parts of the Americas, she would have been classified as his mother, even though the underlying genetic relationships are the same. The point is really here that, and this is just a very, very simple entry-level example, cultures of relatedness vary, they structure marriage and reproduction. That can shape demography in ways that we just don't understand yet, because we don't tend to bring the two areas together. So our group is sort of tasked with trying to build better causal demographic foundations for evolutionary anthropology, and that means building a virtuous cycle between humanistic and scientific methods. I think the first step is to stop thinking about ethnography as a source of data points and start thinking about it as a source of causal hypotheses. If we do that, we can use those hypotheses to build meaningful cultural evolution models and explore their logical consequences. So we're not trying to reproduce anything, we're trying to explore. This is about building a sandbox, a theoretical sandbox in which to tweak things and see what happens. If we can do that, we can use those causal models to design more informative quantitative data collection. And if we can do that, we can use the efficiencies that we gain from this to do more qualitative research, because we need to document emerging phenomena and develop new hypotheses. So central to this program is the reintegration of ethnography into the heart of evolutionary anthropology, but in a way that allows qualitative arguments to be brought to bear on the questions of population scientists. So for the rest of the talk, I want to tell you why I think natural fertility is a giant roadblock in the way of doing that. I want to highlight why ethnography is essential to rejecting it, and I'll do that by showing you some anthropological field research from Vanuatu. I'm going to show you briefly how we're trying to build a natural fertility population in silico from first principles, and how fraught and possibly impossible that might be. And I want to show you how we're trying to use, where we're trying to get to, how we're trying to use ethnography to build better models, and that's inspired by existing research in the Gambia. But first, let's look at the definition of natural fertility. I don't know how many of you have actually seen this before, but this is from Louis Henry's work. He is the father of historical demography, and he is the one who came up with this definition. Fertility is natural if it exists in the absence of deliberate birth control, but the factors affecting it are not solely physiological. Social factors can also play a part. Control can be said to exist when the behavior of the couple is bound to the number of children that are already born, and is only modified when that number reaches some maximum that the couple doesn't want to exceed. This can be broken down into 3 propositions. First, natural fertility is when there's no birth control. That bit seems kind of pretty straightforward. But this only works if you accept the following 2 propositions. That birth control refers only to parity-specific stopping, so something like spacing, delaying, curtailing, all these things do not count as birth control. And third, the concept of natural encompasses all biological and cultural influences on reproduction that aren't explicitly aimed at parity-specific stopping. Now, the purpose of this definition at the time was to try and help us understand populations going through the demographic transition to low fertility. So the idea was, we were trying to work out what's different about, modern low fertility dynamics. And I find it ironic that, demographers who love numbers decided to divide the world into people who like counting and people who don't. But what it effectively does is it lumps all of human prehistory into one category to help us understand a very recent phenomenon, which is kind of, should be, a bit weird for us as evolutionary scientists. Also, natural fertility doesn't have a positive definition. It's about the absence of control. So we're forced to look for absence of evidence in order to identify it, which makes it quite tricky. And this is, this has received a lot of criticism in demography, and it's still there, despite the fact that we know that there are numerous pathways to low fertility that involve other strategies than parity-specific stopping. Daniel Hrushka and colleagues, and Rebecca Sear, who's here, have a great paper looking at DHS data around the world and showing that these fertility declines don't rely on parity-specific stopping. And besides that, historical demographers have been saying for decades that there is lots of evidence of reproductive control in pre-demographic transition societies. We also know that natural fertility isn't the same thing as high fertility. Here's a distribution of total fertility among subsistence farmers in black and foragers and horticulturalists in the other colours. And the point really here is that you can have a low fertility farming population, but you can also have a high fertility foraging population. And more recent work led by Abby Page, looking at this kind of question across different subsistence typologies in 27 different populations, shows that the level of fertility that you're expecting doesn't neatly map onto the subsistence strategy that the population is practicing. Besides that, we know that birth control doesn't require modern methods of contraception. These are just some data from highly developed countries, many of whom have extremely low fertility rates, and many of whom have achieved those low fertility rates without having high prevalence of modern contraceptive methods. And let's not forget that the demographic transition itself began before the invention of those methods. On a sort of slightly similar point, one of the projects that I was doing in Poland was to look at whether different kinds of methods better predicted fertility decline, and what we saw was that more efficient contraceptive methods don't do a better job predicting low fertility. Women are perfectly capable of reducing their fertility, stopping early, shortening their reproductive spans, largely using natural methods. Coming back to this definition, what troubles me the most about it as an anthropologist is that this idea that the natural should be allowed to cover up culture, and for me that's just an illegal move. Henri's definition is weird because he sort of talks about cultural regulations. So he mentioned sexual taboos, for example. And the issue, as I see it right now, is that we're not being asked to think of natural fertility populations as societies without cultures of reproduction. We're being asked to think about them as if those cultures of reproduction do not matter for demography. And that's where I disagree. So anthropological demographers have been talking about this for decades and telling us that what looks like natural fertility at the aggregate can in fact be socially constructed. This is an example from Jennifer Johnston-Hanks's work, and it's a plot showing you the distribution of the length of interbirth intervals in 3 historical populations on the bottom, and the top 2 lines are from African populations who reported using either modern contraceptives or not. The point here is that the difference between the top 2 and the bottom 3 is to do with cultural differences in marriage patterns, so you can ignore that for the minute, but the really important point here is that the top 2 lines are practically indistinguishable from each other. And the point is that means we can't necessarily make inferences about reproductive intentions or action from population data itself. It's not enough to use those aggregated patterns to infer reproductive strategies, and that's as true in the past as it is today. We can't assume that stasis is something that defines our evolutionary history. This is an example from the Neolithic. These are estimates of population densities based on radiocarbon dates in different regions of Neolithic Europe. In red and in light blue are the significant deviations from the null model of exponential growth, which is the dotted lines. And there's little blue arrows that indicate the first evidence of agriculture in each of these regions. And in every case, agriculture is associated with a boom, followed by a crash and a recovery. But in every case, those changes are not associated with regional climate change, which we'd expect it to be if it's a kind of purely ecologically determined scenario. And that just means that the processes generating these dynamics are not strictly determined by ecology, which is what a lot of research assumes. But we don't really have any idea of where to go with that, right? Because we don't really know how to bring cultures of reproduction into this kind of question. So I want to give you some examples of mechanisms that influence different reproductive dynamics, but also how they scale to have important effects at the population level. So if you were at Tom Holding's talk yesterday, you would have heard a bit about Gambian age structures. For many women in the Gambia, age isn't determined by how long you've been alive, it's determined by how you curate your reproductive career. You move between different indigenously defined age categories depending on how that goes. For example, spacing your births and wasting less of your energy. And what happened was actually, famously, when modern contraception was introduced, it actually allowed women to more tightly control their spacing strategies, which actually led to higher fertility than family planning interventions had anticipated. In Indonesian Papua, the historical Marandanim had a practice called Otiv Bombari, in which women had ritualized sexual intercourse with up to 10 men of their husband's clan on the night of their marriage or on their return to village life after childbirth. Now that was intended to promote fertility in a rich cosmological context, but it actually led to widespread infertility once sexually transmitted diseases were introduced by colonists. And as a result, between 10 and 25% of that population at any time was made up of kidnapped or adopted children from other ethno-linguistic groups. In China and elsewhere, cultural preferences for sons over daughters have led to sex-selective infanticide and abortion on a massive scale, which generates skewed sex ratios. And in this case, a staggering estimate of up to 50 million so-called missing women in China alone. And of course, in Germany and many other places, what we might call cultures of childlessness have developed, where we have population aging, with about 40% of Germans expected to be over the age of 60 by the middle of the century. The point is, people are not making reproductive decisions in identical ways in these different cultural contexts, but we don't really know much more about that. And just to really show you how far I want to go with this idea, even the Hutterites, who are constantly brought up as the emblems of natural fertility, a historical population which, by the time they got to America, had a peak of 10 children on average per woman, the highest rate ever recorded, a growth rate of over 4%, organized their entire social structure to facilitate high fertility. Women would supplement their babies after 1 month after birth. Women were excused from labor in numerous different ways to help support reproduction. They have an explicit ideology of population growth. That didn't come out of nowhere. It came from a history of persecution, expulsion, and eventual migration out of Europe to the USA, having almost gone extinct numerous times in their history. And to call this natural, to me, is to ignore the entire cultural scaffolding that makes exceptionally high fertility possible. High fertility doesn't happen by chance, it's an achievement. Growing your population is as much a form of population control as shrinking it. So, I'm going to switch to Vanuatu now, where I've been working since 2015. It's an archipelago of 83 islands, population about 300,000 people. Total fertility is coming down steadily over the last few decades. It was a joint colony of Britain and France until 1980. And it's famous for being extremely culturally and linguistically diverse. There's 138 languages, indigenous languages per capita at the last count, for such a tiny population. And these are all Austronesian languages, in addition to colonial languages, French, English, and Bislama. Vanuatu has a complex demographic history with multiple waves of migration over time that brought different groups with genetic, cultural, and linguistic ancestries of different sorts into networks of contact. And although modern humans got to the region more than 65,000 years ago, it wasn't until around 3,000 years ago that people crossed the sea boundary between what's called near and remote Oceania to reach Vanuatu. So it's seen as the gateway to the Pacific. It's part of this broad population expansion which carried the Austronesian language family out into remote Oceania. In 2018, we published a study that looked at the peopling of Vanuatu. We used a combination of contemporary and ancient DNA. We showed that shortly after the initial settlement of Vanuatu, there was a process of genetic replacement that took place over about 1,000 years, with different peoples coming in from near Oceania. So the plot here on the right just shows the genetic composition of the population through time and the proportion of ancestry from so-called Austronesian sources. Contemporary Ni Vanuatu, the people of Vanuatu, carry extremely high levels of ancestry from near Oceania, and the best fitting demographic model of the process that we could come up with, which is this horrible thing in the middle, is the point of it is that it's horrible, it's complicated. much more so than some simple wave of replacement. In fact, it involved multiple admixture events in the past. And so we argued that the ancestor of the current languages of Vanuatu was potentially used as a lingua franca by the incoming populations, which speaks to this idea that there was ongoing contact between different kinds of population. Now, the reason I tell you all of this is because since then there's been a rapid diversification of languages, cultures, and also genetics. The archaeology and ethnography of Vanuatu shows evidence of extensive trade routes, even within these small little islands, and important interaction spheres. And the point here is that that structures demography, it structures genetic relations between different parts of Vanuatu, and this kind of broadly mirrors the kind of language clustering that we know exists from linguistic research. So it means that we can't assume sort of uniform demographic processes even within one country. We need to better understand things like the organization of reproduction, culturally speaking, and look at it at finer grained levels of aggregation. So that's what I've been doing together with my collaborators in different fields to try and understand how demographic and social processes are generating that diversity, but also how they're maintaining it or how they're eroding it over time. And the group that I work most closely with are the Big Ngambas of Northwest Malekula, which is the second largest island in the archipelago. Big Ngambas are the largest ethno-linguistic group on Malekula, which is itself the most linguistically dense place on the planet. There's 40 languages for a population of about 25,000 people, so imagine all of the linguistic diversity of Europe in a small town. But they have a complex political system which combines elements of egalitarianism and strict hierarchy, so they're not one or the other, which is what makes them so fascinating to work with. They have a clan-based structure. They have an explicit ideology of lineage growth, which rejects modern contraception. So what looks like natural fertility here is in fact highly politically organized and regulated. But even more than that, it's important to not treat indigenous reproductive dynamics as if they're sort of stuck in prehistory. I mean, I think one of the worst things that natural fertility does, especially when it's applied to contemporary societies, is to erase history. It erases why they ended up in high fertility or, you know, not using contraceptives in the way that we expect them to in the first place. So one of the most important elements that I think we need to take stock of is that fertility dynamics in many places in the global south are responses to the colonial experience. They're not stuck in time, they're not frozen in history. And so a big part of my work in Vanuatu is to study the impact of colonialism and today's rapidly changing post-colonial context and its impacts on demographic change. So just sort of thinking about 3 different cohorts over time. If you go back 2 to 3 generations, among the people that I've interviewed, you know, you're in a situation that looks very quote-unquote traditional. You've got strong customary traditions in place. You've got strong use of the indigenous language. You've got rejection of the missions. And you've got, actually, ironically, relatively low fertility. And that's because the indigenous system of that time separated men and women. They didn't live in the same house. They didn't reproduce constantly. They weren't, you know, for want of a better way of putting it, they weren't having sex all the time. And the cultural system organized that. Go back 1-2 generations and you get into the kind of colonial context and you see the erosion and the subsequent revival of customary traditions and language. You get the exclusive Christianity taking over, which had massive impacts on how, you know, people's domestic lives. They were forced, men and women were forced to live in the same home. The traditional methods of contraception were banned. Traditional methods of separating men and women were banned. And this led to a massively rapid increase in fertility driven by these missionary interventions. Come to the current generations and you're in the post-colonial context and you're talking about a scenario where customary knowledge has been mostly lost and is trying to be reclaimed. You have massively diverse Christian denominations which are sort of mapping onto clan politics, so every clan and every lineage has its own church. And you have the beginnings of the demographic transition as market integration becomes much more important. And I got really interested in thinking about how to get at the cultural mechanisms that are influencing fertility by thinking about infertility, actually. Because infertility is a really nice way into understanding how social technologies of reproduction are actually mobilized to deal with things when they go wrong. The World Health Organization defines infertility as a disease as a biological dysfunction in a specific embodied location. Now, there's no assisted reproduction in Vanuatu. Infertility is not on the development agenda because these are the kind of places where it's desired that fertility goes down. So it's handy. But for the Big Nambas, reproduction isn't understood to be determined by physiological limitations. It's not even relevant most of the time. For Big Nambas people, it's about your social comportment. So if you haven't behaved appropriately, if you have violated some of the norms of the group, it may well be that you end up being infertile for numerous reasons. So infertility in and of itself isn't interpreted as an inability to get pregnant, but an unwillingness to, a form of refusal. And so it's seen as an attempt to block the patriline and its continuity. And so infertile women are in fact met with responses that seem very strange from our perspective. Things like anger, demand for extra labor, increased sharing of goods and resources, compensation payments to clan heads, and to the policing of women's movements, the withholding of food, information, and in extreme cases, even social contact. And that doesn't make sense from our perspective, but it does when you understand how reproduction is understood in the Big Nambas context. And that's because reproductive activity, and therefore also responsibility for it, is distributed among the in-marrying women of a patrilineal compound. So the costs of infertility are also borne by all of its members. You might say this is a kind of cooperative breeding, and it is, but it's cooperative breeding in a way that we are not used to talking about. It's about, there are specific cultural mechanisms that determine how that reproductive effort is pooled. So for example, kinship terms blur the distinctions between in-marrying women. All in-marrying women are referred to as mother by all the children. There are levirate marriage conventions in which you can marry your deceased husband's brother, but only in a certain direction of the birth order. And what that does is it keeps women in the patrilineage as reproductively active members, but it also frees up firstborns to contract polygynous marriage. Non-genetic children born outside of wedlock can be incorporated through specific rituals. They are literally, culturally made into kin through particular kinds of compensation payments. And as I said, there's a firstborn prerogative in the society, so if you, as an oldest son, don't have a son of your own, you're free to take the son of your brother and treat them as your son. And, there's lots of things going on here which create strategic pressures between reproducing couples, between lineages, between patrilines, and strategic infertility, including abortion, is a part of this. So there's very strong demographic competition between clans and lineages. As a result of that, there's also extensive supernatural warfare over reproduction in the form of sorcery attacks and the use of ancestral male power to attack women. I interviewed almost 180 Big Nambas women, and the vast majority of them suspected some sorcery attack during their pregnancy. The irony of this is that it actually reduces their desire to have large families more than any other factor that I could measure. The question is this natural fertility or is it just patriarchy? We have things like distributed reproductive agency. We have what's called negative agency in terms of refusal to reproduce, which is a woman's greatest power in this kind of society. We have strategic infertility that is happening at lots of different levels, and we have reproductive leveling through supernatural warfare. We can't just wave all of this away under the idea of natural fertility when it exists in this very rich set of indigenous ideas about reproduction. To do so is to just like tie our hands behind our back. There's so much more work to do. So with all of this in mind, one of the issues in the group we're trying to deal with is, what would a natural fertility population really look like in principle? So what if we tried to build one in a modeling framework? What would we have to do? So we were thinking, let's try and restrict it to the most basic biological parameters and see if that would help us. And doing this is part of a much bigger effort to develop a new software environment, which Tom Holding, who's here, is leading, to help researchers who don't usually use modeling to get off the ground with building agent-based models, specifically to do with understanding demographic phenomena. And we're doing this in collaboration with Adam Powell at the Max Planck and also with Richard McElreath in the Department of Human Ecology and Behaviour. And our challenge is basically to figure out ways to instantiate verbal qualitative arguments from ethnographies or from your own head into a set of causal claims. And that's the hard bit, really. and what we want to do is make it easier, once you've done that, to explore how those cultural assumptions impact demographic phenomena. So part of this was, we were trying to make it easy. This is just a schematic of a basic modular system that we're trying to build. This will be a baseline kind of drag and drop thing where you can drag little modules that will give you demography for free, basically. And in trying to develop a baseline for this, we were trying to come up with a sort of acultural model of fertility so that we can know when a cultural feature actually changes it. And it turns out that that's incredibly difficult to do because natural fertility, as I said, doesn't have a positive definition, it has a negative definition. It's defined as an absence of something. So it was very difficult for us to know how to start. So we started here. What we know is that from the empirical literature, there are certain expectations about what a natural fertility population should look like at the population level in the aggregate. So there are these characteristic patterns, so particular age-specific fertility rate distributions. There's this assumption, and this will become much more important later in the middle, of sort of stable interbirth intervals across the lifespan. So that's one of the assumptions. And when you break those down, there's this idea that interbirth intervals get longer as you have more children, depending on what parity you're at. So these lines here just show women, the group of women at each parity. So people having 12 plus children, people having 11 children, 10, etc. And their interbirth intervals get longer as they get older, effectively. But these are the kind of things that we expect to see. And so the question became, what are the absolute minimum requirements of a model of reproduction that could potentially generate natural fertility profiles like this? So Tom built an age-based model. It moves through a simulated life cycle based on a small number of parameters. And this is it. This is all the stuff that's in the model, basically. And this is already horribly complicated. And because we know natural fertility doesn't have to lead to high fertility per se, we also simulate low, medium, and high fertility outcome scenarios with these different kinds of combinations here. So all of this has turned out to be really hard because we had no idea what the first principles should be. So we had to look to the empirical record to try and find out, to anchor our parameter ranges on the evidence that's out there. But it turns out there are very few vital rates out there that aren't already influenced by culture, which makes it quite tricky. So for example, if you want to model, you have to define what counts as the probability of having a loss per pregnancy, for example. And so the top plot here is data mostly from medical sources looking at the age-specific probability of a miscarriage or a stillbirth per pregnancy. And in all of these plots, the grayscale lines are our parameter ranges overlaid, just to show you really that we've tried to anchor it to the best possible empirical evidence, but of course that's already setting us up for failure to some degree. And on the bottom, we have the age-specific probability of pregnancy per month, and this is coming from natural fertility population. Other kinds of parameters that we wanted to know are things like, once you've had a child, how long does it take to get back to a baseline level of fecundability? And the point in the top two of these plots is that, what's the maximum kind of biological inhibition in terms of, like, let's say, lactational amenorrhea, or the minimum inhibition in the middle one, where you're looking at minimal levels of breastfeeding. Now, as I said, we're assuming this is all sort of biology, but of course it's easily culturally controlled, and there's no way to disentangle the two without more data from diverse populations. So this exercise has been very useful in showing us how little we know, first of all, and how much more of this we need. But just to kind of ground truth the model, this is a summary of the behavior of the model overall, and how it affects total fertility, including all female agents in the solid dots, and then the completed fertility agents in the empty dots. And the only point I really want to tell you is that these are sensible outcomes. We can reproduce reasonable expectations of how reproduction should work. So for example, the first column here, the pregnancy rate in blue, all it shows you is that the higher we make the pregnancy rate, the higher fertility goes, makes sense. In orange, the higher the loss rate, the lower fertility is. In green, the weaker the inhibition on pregnancy after a birth, which is first little dots, the higher fertility your population will have. These are all sort of simple checks to make sure that this model makes sense. But the real question we have is, can this simple model generate something that looks like natural fertility profiles in the empirical record? And when it comes to age-specific fertility rates, the answer is sort of yes. So first of all, the top three plots show you empirical data. So you have natural fertility, age-specific fertility rate profiles, you have controlled ones, and then we've normalized them so that they can be kind of fit together, and they look more or less the same, except you see that the slashed lines are sort of pulled in, which is to do with stopping early. And our results from the simulation are at the bottom, and again you see that sort of deviation at the beginning of the interbirth interval, at the age-specific fertility rate. You know, the lines are pulling this way a little bit, which is to do with marriage, basically. If natural fertility were purely biological and didn't involve any marriage or mating markets, then there would be very little delay in getting started reproducing, but of course there is in the real world, so that's why those empirical lines are pulled in a bit. Okay, what about interbirth interval lengths in the aggregate? So I mentioned this flat line that we tend to see in natural fertility populations. The answer here is that we can't really reproduce this, and this is where it gets quite interesting. So in all cases we see a shortening in the aggregate interbirth intervals at the highest parameters. We don't see a straight line, that's the main thing. We see a dip coming down. And when you break it down a bit more by parity, you see this disjunct a lot more clearly. So here on the top and on the bottom we have the empirical and the simulated data. Each line again represents the subset of individuals who ended up having a particular number of children, you know, each line going up is a subset of women at a certain parity level, and the line indicates the lengthening of the interbirth intervals as they go through their reproductive career, getting longer as they get further along. So for any given level of completed fertility, as you have more children, the length of time between them gets longer. And in the top plot, we really see this mismatch because that aggregated line, the brown line, is giving us this picture of stability where under the hood there's a lot more going on. But our data, or our simulated data, shows a clear dip at the higher parities. And so we've also noticed a few other things about this. There's kind of 3 points of departure that I offer up as, you know, food for thought. I'm not saying this is, you know, how it is, but this is what we're finding. So first of all, we're seeing surprising to me, when you think about it, an increase in the interbirth intervals at the earliest phases of reproduction, when we should really expect reproduction to be faster, right? We should expect early reproduction to be faster than later reproduction, so we should see this dipping rather than going up ideally. In midlife, we see reproduction sort of slowing perhaps more than we might expect, and maybe that's an artifact of this first part of the curve, but we just don't really know how to explain it. And at higher parities, as I've said, we see these birth interval lengths dipping dramatically, getting a lot shorter. And this is where modelling really comes into the fore, because we've modelled it, we can disentangle why that's happening. There's two counteracting forces going on here. One is selection bias. So assuming no age-related decline of fertility, we end up with selection bias at the highest parities. So once people get to a certain fertility level, basically the sample is increasingly composed of those very lucky individuals who've had short intervals all the way along, and they pull down the interbirth intervals at the highest parities. And that's actually something that Henri himself noted in the 1960s. He said there's often too few observations at the highest parities to accurately sort of estimate the length of these final interbirth intervals. And you know, there's various sort of knock-on effects of finding that basically having this aggregate curve getting sort of pulled down at the higher parities is one thing, but also any sort of heterogeneity in the timing or the spacing of births in the population in general increases the influence of that selection bias. On the other hand, we looked into this in a bit more detail to try and see if empirical data could help us a bit better. So we weren't really sure whether the birth intervals are actually shorter at higher intervals, at higher parities or not. And basically looking at African DHS data, we can see that there is a clear selection bias going on in contemporary populations. So you do see people who have these very, very high numbers of children having shorter birth intervals between their children on average, and that is, it all makes sense, but these are lucky people. They're lucky to get that far, is basically the point. And you know, we'd need much bigger samples to be able to detect this really well in so-called natural fertility populations, small-scale populations. The other counteracting force is that, of course, age-specific things matter too, but they matter in the opposite direction. So as you get older, you're more likely to lose a pregnancy, or you're less likely to get pregnant in the first place. And that reduces the total number of pregnancies as people age. That actually lengthens the average birth interval over parities, and these two things are basically counteracting each other. And they're very, very hard to disentangle in empirical data, but that's the beauty of modelling, is that it allows us to do that. So just to simplify this, we basically have two different kinds of bias that are counteracting each other and that are giving us the picture of potentially stability where there is none. What's really interesting for me is that in order to get an empirical pattern like this, you need age-related spacing in two of those 3 points of the curve that I mentioned, either early reproduction or amongst the highest parity women, or somewhere in the middle of the reproductive career. And the interesting thing is that spacing needs to be quite consistent across individuals to not introduce heterogeneity and therefore amplify selection bias. To get that kind of spacing consistent in a certain age group seems to me to not be a biological phenomenon. It seems to me to require some sort of cultural constraint. And so the question now becomes, is the apparent stability in natural fertility birth interval distributions actually in part due to cultural rules or preferences for spacing births? It's obviously, of course, the outcome of biocultural processes, but ones that we don't fully understand. So just to summarize this, our model produces semi-realistic fertility outcomes anchored ultimately on very patchy data, which itself is probably already culturally confounded. Nonetheless, we can produce age-specific fertility rates, but not stable birth interval curves associated with natural fertility. The differences between our modelling and the empirical data indicate, firstly, cultural influences on age at first birth to do with marriage, these deviations from what you might expect otherwise, and spacing at early and potentially at higher parities. We find that selection bias is strongest at the highest parities, not seen. We don't really see this in natural fertility populations, but we do seem to see it a bit in the DHS data. And we also see that age-related changes, particularly to do with declining pregnancy, rather than increased losses per se, increase heterogeneity in the population, and that only amplifies these kind of selection biases. So, so far so fun, but a broader point is that if pregnancy rates really matter, then we're into new territory here, because pregnancy probabilities are culturally determined by cultural rules everywhere. It's obvious that changing different parameters will have massive effects on demographic rates, and the point is to be able to model these effects in better detail now based on the ethnography that we have available for specific populations, rather than just this universalizing assumption about how all human demography works in every place and time. And of course, most societies in the world also practice some form of postpartum abstinence, and these parameters are exquisitely sensitive to local cultural practices. So I want to spend the last 5 minutes just giving you an example of where we're trying to get to with all of this, why we're doing this in the first place. We want to explore diversity in demographic regimes around the world. So if you were at Tom's talk yesterday, he talked a bit about these indigenous age categories in the Gambia. He was talking about cultural menopause, and I'm just going to sort of riff on what he said a little bit. So in the Gambia, as I said, aging is not about time per se, it's about reproductive events, it's about your ability to navigate the stochastic impacts of a reproductive life in a high fertility context. And in the Gambia, in this particular population, this is inspired by Caroline Bledsoe's work, there's an indigenous age system, and these are the indigenous age categories here, and the biological age ranges next to them. So just focus on the highlighted ones in the middle. The point is they span the entire reproductive age range. So which one of these you fall into depends on the effects of births, miscarriages, losses, insufficient recoveries after childbirth, stochastic events that use up units of energy that are indigenously considered to be called muscles. These are God-given units of energy. You don't know how many you have, and once they're used up, you get culturally moved into Sarifo, which we're calling cultural menopause. Becoming Sarifo means you are retired from reproductive life. But because there's a huge amount of variation, in the random effects that can happen to you over your lifespan, you can end up being Sarifo anywhere between at least 29 and 47. So this isn't just a cultural mapping onto biological menopause. This is something different. And the point here is that ethnography is the only way to get this information. You cannot get this a priori, and it's different in different places. And to understand that, we need to understand how reproduction is regulated by these categories and identities in this place and time. So the hard work is then to try and take those insights and build them into something that looks like a model that we can then use to simulate the demography and see what the impacts are. So that's what we've been working on for the last 2.5 years, I think. And the whole point of this is just to explore the implications of that demography at scale. And here's just some basic parameters that might go into it. So we define simple rules about reproduction of Serifo women versus non-Serifo women. We simplify how many units you need to spend in order to move into post-reproductive category. And the next step really is just to simulate the population level outcomes. So, and I repeat, this is a toy, this is a plaything. We're not trying to predict particular outcomes. We're trying to understand what happens if you tweak the dial that way, what happens if you tweak it that way. So here I'm showing you birth and death rates over time and age distributions under 2 different scenarios. On the left is the sort of natural fertility model of population growth based on biological age counting. So you're counting calendar age. It's growing rapidly. On the right, you see the exact same model, except we also incorporate these cultural age groups. And here you see that the growth is a little bit slower. The population pyramid is a bit more narrow and old. So what's happening here is that people are moving into the Serifo age group once they've used up their muscles, so that's the yellow line here, removing them from the reproductive pool. Okay, imagine now that we are a family planning policy program and we drop an intervention that gives free contraceptives into this kind of a context. What happens? So in the baseline model, contraceptives decrease the growth rate, as you would expect. But in the cultural age structure model, it actually slightly increases the growth rate. And that's not what we expected, but it's what actually happened in real-world Gambia. And the reason it happens is, again, because of our cultural mechanism. Because with contraception, women end up wasting fewer of their muscles, they efficiently space their births, they have more muscles to use, and they have more live births overall. They move into that Serifo category later, so that arrow, that yellow line is shifted into a later age range, and at a lower rate. It keeps them in the reproductive pool for longer. I think this is really cool because it shows you that public policy interventions are interventions on cultural systems, not just interventions on biology. It shows us why interventions that don't take culture into account can have unintended consequences, and it gives us insights into how interventions can themselves change the cultural features. So if fewer people over time become Serifo, maybe that age category will become less culturally salient. And this is precisely the kind of thing that cultural evolution should be trying to understand. So the point here is we need to take indigenous categories seriously because they are the reality that people are reproducing in, and translating them into a form that lets us explore if and how they modify already well understood demographic processes. We can make a lot of progress here. We can borrow tools from demography to do all of this. And I think that will transform our ability to instantiate hypotheses that come from ethnographic sources and increase the precision of our hypotheses. But obviously we need to know the ethnography before building the model. So I want to finish on 2 thoughts. The first is from Frank Notestein, who was one of the major contributors to demographic theory, demographic transition theory, sorry. He's a huge, huge name in demography. And even he said, we can take it for granted that populations that survived into the modern period had both the physiological capacity to do so, but also the social organizations necessary to produce high fertility rates. So high fertility, I say, again, it's an achievement. It's not a state of nature. There's enormous diversity in how we do all of this. We have no idea how it affects demography at larger scales. If we're going to take culture seriously, we can't just regulate reproductive behavior, which is central to human social life, to some sort of pre-conscious, unregulated state for most of human history, or some sort of self-organizing set of dynamics without any historical or political context. So getting rid of natural fertility, focusing on feedback between culture and demography is the first step to doing that.